is a linear combination problem. And what we need to do with it is get rid of a variable. So you have 3x minus 2y is equal to 6. And you have 2x minus y is equal to 3. And so the question here is to figure out what's easier to make opposites. You know, to make 3 and 2 into opposites. Like, what number does 3 and 2 both go into? Right? And they both go into 6. So to make, when you're changing these, you're always multiplying. And you'll multiply throughout the whole thing. So you can multiply through by 2, or you can multiply through by 3. And one will be opposite. Or you could look at these two and say, well, actually, it'd be easier if I just multiplied one of the equations by negative 2, because then that would change this into a positive 2, and a positive 2 would be opposite of a negative 2. And so that's why we would choose multiplying this equation by a negative 2, instead of multiplying this equation by 2 and this equation by negative 3, or vice versa, negative 2 and positive 3. Okay? All three of these situations work. Okay? It's just this is our easiest one. And so negative 2 times 2 is negative 4x. And negative 2 times a negative y is positive 2y. And a negative 2 times 3 is a negative 6. Okay? And then this equation just gets brought over. 3x minus 2y is equal to 6. And so what happens here is we add these two equations. These 6's cancel, and we get 0. These cancel. There's really a 0 there, right? And these add up to be a negative x. Okay? And so a negative x is equal to 0, because negative x plus 0 is just negative x. And so I can solve by dividing by negative 1, but 0 divided by negative 1 is still 0, so x is equal to 0. Okay?
Why is 3x minus 4x? Well, actually, that's a 1x.
The invisible one.
Yeah. So now I want to grab an equation that I can plug this into and solve relatively simply. So we're solving for y, so we want to grab the easiest y. So the 2y or a y, and in this case I would choose the y. So in this case I would plug in the 0 for x and get 2 times 0 minus y is equal to 3. And 2 times 0 is 0. And 0 minus y is equal to 3. So then y minus y is equal to 3. Right? And so now we're going to divide again by negative 1. And what happens here is the y becomes a positive, but the positive 3 becomes a negative. And so now we have y and x. And with these two, we can create the intersection at 0, negative 3. And you have to be careful how you write that, because you have your x, right? You have your x. And the way I'm going to do this, I'm going to write this. So you have your x in blue, and you have your y in black. Okay? And then I'll put the rest in red. Okay. So we have our intersection at 0, negative 3. Okay? And that means if I were to graph these two equations, right, then they would intersect at 0, -3. Okay? And just to clarify that, we can graph them relatively quickly, okay, by using that technique, that alien hand technique, or the intercepts technique, which is plugging in zeros for each of them. Okay? So if I plug in a 0 for x on this equation, then that gets rid of the x. So divide the -2 into 6, and I get -3. And then if I plug in a 0 for y, that gets rid of the y in the equation, and I get 3x equals 6. And I divide by 3 on both sides, and I get 2. And so I have 2 points to that line. And I'm going to make that point a red point. So 2, 0 means I'm going in the 2 direction on the x, 0 in the y. 0, 3, 0 in the x, but -3 in the y. Okay? And then I can draw my line. Okay? And then in the other one, I'll do it in blue. And let's just say that we put a 0 in for x. Then that gets rid of that, and I get -y equals 3. So y equals -3. And then if I plug a 0 in for y, that gets rid of that, and I get 2x equals 3. So I get 3 divided by 2, which is 1.5. So the blue is going to be 0, -3. So that one sits on top of that red line, red dot, right? The other one is 1.5, which is right there. And so this line looks like this. And that's how they cross. Okay? And that's linear combination.